Hello everyone, my name is Alberto Marquez. In this video we will discuss in the basic processes of Arena how to use the module decide. Here I have created a model. The module has the standard create entity with time between arrivals exponential, and then it goes to the first process. In the process, we only have a delay. And then after the delay, we need to decide. This decision is by chance decision, that it's a random decision. The alternatives we have are two-way by chance or n-way by chance, and we can just add the probabilities, and I will explain that in a moment. We have two-way by condition, in which we would need to check for a condition that will be demonstrated soon, and n-way by condition. In this case, the selection is n-way by chance. And what we have here are the percentages of likelihood for these events to happen. We have 20% chance of going in the first branch, 30% chances of going into the second branch, and 40% chances of going into a third branch. Notice that this does not add up to 100%. So anything that is not going to either one of these three branches will go to a default option. So if you look closer to this module, you will see that you have three branches coming out. One is the decision associated with 20%, the first one, 30%, the second one, and 40%, the last one. But there is another one that it's marked as else. That is, in case none of those three happen, what will happen with the remaining, in this particular case, 10%. And what I did in this module is I routed that to be going back to the process, to the previous process, and this would be a model in which we have some sort of reprocess of the first, for the first kind. Maybe you're letting paint dry and that's why it's only delaying, and you realize it's not dry enough, and then you need to let it dry a little further, and then after that you send it to maybe three different finishes, three different alternative finishes. So in each one of these alternative finishes, the entities will go there and be processed. In this particular case, it's only delays. So maybe it's some sort of furnace in which they're just cured at different temperatures. So it is not taking a significant amount of space or significantly number of resources. And we just model it like that. The purpose of this video is mostly to show that we can branch the flow or the pattern of the entities as we wish. Let's consider a different model. I will create from scratch. So I will close this and I will start a new one. For this one, I will create the entity, and maybe I will have, for the first time, two creates. And after the creates, I will have assigns. I will have two assigns, one for each entity. So I need to make the proper connection between the modules. And now in the assign, I will be assigning to an attribute in which I can call here you have entity type, but I can call the attribute is the color. And I will have a catalog of colors, but let's say this is color 1. And for this one, I will select a different color. So it is an attribute. Remember, attributes are characteristics that are pertaining to the entity. And so the entities that go into this second create, they are color 2. So once we have these two entities, maybe both have to compete for the resources in a particular process. And for that, this process is faster. So let's say that it takes 0.4 on average, from 0.2 to 0.4 to 0.6, on average 0.4. And it's a CZLA release in which it's just using machine 1. And it takes one machine 1. Okay. Now after it uses machine 1, what we want is to select based on the color. So we are going to include a decide. And here in the decide, this will be a two-way condition in which we're going to check for an attribute. If the attribute is color equals 1, it will take that branch. Notice that I'm asking, is color equals 1? And here we have the branch for when the color equals 1. For all colors, other colors than 1, it will follow the other pattern. So after we do this, we can include maybe 2 more processes. One process for the associated with the color 1, and another process associated with color 2. We can do all kind of decisions. Maybe after we do this process, we go to this other process. So regardless, one will require an extra process and both will need process 3, and then after that we will dispose. And with that, we have a model for which we have a decide that is based on an attribute. We assigned attributes, and we can control, say for instance, if we have several more entities of one type than the other. Let's say the time between arrivals for this one is 10, but the time between arrivals for the other is just say 10 times as large. So that means that we don't have as many entities coming in. And to make sure that we can have CZLA release for a second machine, let's call this machine 2. And we could have yet another machine, CZLA release, for another resource yet called machine 3. And these the 3D machines are 3 different type of machines, but we only have one of them, one of each type of machine. I will increase a little bit the processing rate. to ensure flexibility in the queuing lines. Of course, you wouldn't have to do this. In practice, you go with the distribution that it's adequate to represent your system. And we're ready to run it. Now you will see that there is a queue that is forming in process 2 and in process 3, but they are not equally large because most entities have to go to process 2, while only 10% of the entities just go to process 3. So, eventually the load for process 3 should be the summation of both process of the entities associated to 1 and the process of type or color 2, but not necessarily most of the entities actually go directly to process 3, because most of them have to go first to process 2, because process 2 is associated with the most likely event of them being entities of color 1. So this is another video on how to use the decide module. You have the opportunity to use decide using random chances, random branches, 2 branches or more. And in a similar way, you can have 2 or many branches for a logic decision depending on a condition.